Hi, pre-calcers. This is Mr. Holt, just walking us through the basics of function notation. This is lesson 2.2. So function notation is really just a way of representing the output of a function, whatever that function might happen to be. We notate it with this kind of notation where there will be the name of the function over here. Usually f is kind of the generic one, and then x is sort of the generic input. This is just a way of representing whatever the output happens to be for the function. This can be really handy if you're dealing with a whole bunch of families of functions where you might have multiple different outputs that you care about that represent different things, or you're using the same input or different inputs for the same and doing the same process on it over and over again. So it also indicates the input of the function at the same time. So this is going to represent, this whole thing is going to represent the output of the function, right? It's equal to y, but it's also specifying what the input is for that particular output. All right, so f of x is basically one mathematical object. It's helpful to think about this. This is not f times the input or anything like that. This is just one mathematical object. It's telling you the output for a particular input. So it tells you what that whatever that input is, it's going to tell us what the output is going to be. So for example, if you have a function that looks like this, f of x is x squared minus x plus 3, really what that's saying is that we're going to take whatever the input is, we're going to square it, then we're going to subtract that input, and then we're going to add 3. And we're going to do all three of those things together. So, for example, if I have the function, or for that function, I have the input 3 minus d, what I'm going to do is I'm going to take this input. The first thing I'm going to do is square the input. Then I'm going to subtract the input, and then I'm going to add 3. And so that's going to look, we'll work through that in the next one. Just as a follow-up question, kind of as we're working here, I'd like you to think about maybe, does f of 3 minus d, is that just going to equal f of 3 minus f of d? Does it simplify that way? So think about that, kind of keep that in the back of your mind for just a moment. Maybe make a prediction. You could make a prediction, write that down, and we'll check it in just a minute. Okay, so we're going to evaluate this function for 3 minus d. So again, first thing we're going to do is we're going to take that input and we're going to square it. So the 3 minus d is going to go in the place of the x here, and we're going to square that whole quantity. Then we're going to subtract the input. So then we're going to subtract the quantity 3 minus d, and then we're going to add 3 at the end. All right, so I'm going to have to square this quantity first. Keep in mind, I'm going to have to use FOIL and remember to double distribute all the way through. We're not just going to square the 3 and square the minus d. So if I do that, if I use my FOIL, that's going to give me 9 minus 6d plus d squared. Then I subtract the quantity, so that's going to be minus 3. The double negative here will cancel to give me plus d, and then plus 3 at the end. That's going to simplify to this, writing it in standard form, d squared minus 5d plus 9. And I'm going to leave this for you to check, but if you go ahead and evaluate f of 3 for this function right here, and then subtract f of d for this function right here, you will not get the same result. And you can prove that to yourself. But just the short answer, no, you should not expect that you will get the same thing just by this. So most functions do not have a sort of distributive property like this. All right, that's it.